So I've been recently getting back into redstone. I used to do it a while ago. Didn't release videos about them though. But and I saw this technical redstone side of Minecraft. People building computers, doing binary operations, and all sorts of different types of stuff with just redstone. And I got into that. And then I saw this Matt Bat Wings video. That was the guy's name, of him creating a sorting algorithm in Minecraft. And he challenged us to make one faster, and that made me think of building this. Alright, so what is this? This is my implementation of a shell sort algorithm, if you've ever heard of that, and maybe if you've ever done some computer science. And you enter redstone signal strengths using barrels that I have already. Like, each of these barrels have a different redstone signal strengths from 1 through 5, 6 through 10, 11 through 15. And here, actually, let me just do an example. I'll just grab some of these. A little bit more. Alright, and kind of just place them random order. And, oh, missed one. If we go to the end, like, if we open each of these, like, it'll sort them greatest and right to least greatest in the left. So this one is 7, 9, 15, another 15, another 15, 13, 5, 8. Like, there's really no order that's in there. And if we go to the end, it has sorted them. The 3 15s that we saw, this one, the 13, and so on. And you can see their strengths right here. 15, with this texture pack I have, 15, 15, 13, 9, 8, 7, 5. Alright, so how does this work? So, in that Matt Backwings video I saw, he showed off this design made by another person called Oscar91, where it takes two inputs of redstone signal strengths, and here, let me just take some examples, and a lever. So if we do different signal strengths, like that and that, these will both be 12 and 14 on the output. And if we put these, if no matter which ones we have turned on, the 14 will always override the lower value. So the greatest one always comes out on top of the other one. So the greatest one will be sent in here, and then inverted by subtracting from 15, so which just inverts it by its max value, and then that is outputted on the right because it's the max value. And then if we go below here, it will this time, so if a thing is inverted, it will become the lesser than the 2. If this one is originally greater than this, and put in here, and then inverted, its inverted value will be less than this one's inverted value. I don't feel like explaining the math. It's pretty easy math, you can figure it out on your own. But these are another 15s, and it puts them both down here, inverts them first, then puts them on the same line to put this one, which is now bigger because or greater because it was inverted first on this on this redstone signal strength, and then outputs it here. But now it put them in order, but they're inverted. So what do we do? In the video, Oscar91, he made the sorting algorithm, a bubble sort algorithm, which kind of takes a bunch of values. Just pretend these are a bunch of signal strengths. If these two are greater, Actually, this is a really bad way of explaining it. Here, let's just make it look like that. If this one was greater than this one, it would swap them, go to the next set. If this one's greater than this one, it'll stay, otherwise swap them, and continue that, and just keep repeating it until they're in order. And what he did is he took this set and then duplicated it and put it on the ends to invert them back, but backwards, so it puts the greater one, which is now the left side, inverted, and then inverts it and then puts it on the left side so it's all in order. And you can go watch his video, he explains it better than me. And I was thinking it was a pretty big design just to swap them, which ones are greater, so I kind of, in my design, copied this and put up 2 subtractors, because we need to invert them back, is my thought. I could do it much simpler. Whoops. And we have a 15, and it inverts them back. And then we have our redstone strengths we can read from here in the right order. So if we get our signal strengths, like 5 and a 2, no matter which order we put them in, the 5 will come up here, and the 2 will come out here. And if I just get my axe back here, I remove these. If we put the 2 over here this time and a 5 here, the 5 still comes up on this side, and the 2 is over here. And it's much smaller than their design, and it might not be as fast because we need to stack them next to each other, and this will interact with the other one beside it. I found ways around it, and so it works pretty well. But that's pretty much the system that I kind of copied from them. And I made a shell sort, which is kind of, here, I'm going to use the same thing I had, there, the same idea I had going on, like a bunch of values, like that, and then, so the way bubble sort is it checks these 2, swaps them depending on their values, and then goes through and repeats that, but I don't want to just constantly repeat it, and I don't have no way to check if they're sorted, and I want a definite way to know it is done. And I found a quick and fast and efficient one called shell sort that starts at half the whole list's length, which will be right here, from here to here, picks a gap like that, compares these 2 values, swaps them depending on that, shifts up one, compares this one now with this one, and so on to the end, then divides that by 2, so now it goes to this one, compares them, goes back, but if it gets to a spot where it's comparing these 2 and this one, since they have another gap going all the way back to start, once it compares these, like let's say this one is greater than this one and swaps them like it should, but this one is also, this one is also greater than this one, so it swaps them and then swaps all the way back to the beginning, and then it repeats that, counting up by 1, and then it divides in half until it gets down to a gap of 1, which is just the ones next to each other, and does kind of like the bubble sort thing. Goes through, swaps them, and then it is done sorting. So, and I had a lot of trouble making this in Minecraft, because as you can see, it's very huge, much bigger than the ones that the Metbet Wings had. And although it is pretty slow, and I made it really unnecessarily big, I could probably make this much more compact and fast, but this is close to as fast as it can possibly get the way I made it. If other people in the comments can find a faster way, or other viewers can find a faster way to implement shell sort, feel free to let me know. But it does that thing where it can comparing this value all the way down to this one, plugs them into that setup we had going, inverts them and then puts them back out, and then repeats that kind of, you can see it going diagonally, divides by 2, and then you can see it kind of, once it does this one, it repeats, and then it checks all the way back down to the start. And I kind of stacked it, and then it does that all the way to the end. Now, this one is obviously not faster than the ones they had in the video, and his challenge in the video was to make one faster. But theoretically, this would be much more this will be like this same length, just extended out with more data. Will do that other data in the same exact time as this one. You cannot. You almost think you can extend it out infinitely, and it will sort it in the same time. Theoretically. It is much more efficient than bubble sort than the others, but in the video they were only working with 8 different values being sent in, which is what I did, just for examples. But if they did more data, it would take much longer, and this one, I think, is faster for all different types of lists. And that's what I've been working on so far, and I was thinking about plugging into this machine, which uses shulker box randomizers to generate a bunch of random values throughout all these different things, and then I can lock it in place. And I don't feel like explaining this. This is a pretty simple circuit, like data memory right here that stores its whatchamacallit. I can't think. I'm sorry. Oh, wait a minute. I just found a flaw in this thing. Wait, let's see if that actually... Sorry, this is not... Alright, it still works. Just don't worry about that. But it stores the shulker box value into these things, resets them if it gains another value, and then stores it, and so on. Don't worry about what I'm doing here. And then once it gets to the end, they're kind of far apart, and this thing puts them one block space between them, and then I can just flip this lever. Whoops, I'm holding the X. Flip this lever, and it lets all the data values through, and I can switch it off. And I was thinking I could just leave that lever on and let all of these values continuously go through this. But then I realized that that would not look like it's sorted in the end, because it is not synced. Like, if you see this big circuit going through, doing all the kinds of swaps, while this one is just being continuously going out, some of the data gets to the end faster, and you'll see like mixing between different sets of data, and so on. So I would only have to like click this for a little bit, let it choose its data, move it off, and then flip the lever and send it through this. Which I'll probably, hook up that now. Alright, so now if we go to here, / copy, and then we can just put this setup going here. And just paste it. There's our huge machine right here. And then we have our data. There's a lot of comparator bugs. This will happen when using World Edit, and I'm pretty sure if I just send some data through, it'll update. If not, I'm gonna have to go through this whole thing and update all the comparators. Let's just hope it updates the values when I send this through. Let's go to the end. Yes, it does take some time. Oh, it updated them. So you see how it sort of staggered away and it didn't do it all instantly? That's because it's not synced. But it did compare them. And I'm kind of curious to see how it will handle if I just let this lever go. This might not even look close to being sorted. It is a bit laggy, of course. If we go to the end. Oh, wow. Oh yeah, you can see some of the mistakes because of it not being synced, but it looks pretty good, like it's doing it pretty good. It is not getting data here for some reason. That is so weird. I am very curious why it's not getting data there. Yeah, you can see along this whole line. Oh wait, it's getting data through everything. So where is the data being lost? Oh, right here, right here. Yep, it's being updated every tick, and comparators don't respond that fast, so some data will not be displayed. Just like I was afraid of. I knew there would be a problem with it being updated that fast. I think we can just solve that problem though, sure, by just doing that, making this clock longer. Uh-oh. Oh no. Pulse generator here. Alright, and we're back. So I did fix it, made a bunch of one-tick pulse generators, and then extended them and so on to make it work a little bit better, so hopefully this will work like it's supposed to. And I think I see it. It looks like it's working fine. Yep, some of the data is a bit slow. Yeah, and you can see how staggered it is, because the data is coming in slower, but it works pretty well. Yeah, this data is for being a bit slow on that side of these two. The third one's actually doing well, but see, it's sorting them pretty well with it not with it for it's sorting pretty well for how not synced it is. Yeah, look, you can see how it's coming through at like a one tick pulse because of how it's set up. The different datas. You can see the different. That's cool. You can see the different data values being stored through. Yeah, I had fun making this. Like I was saying, I will be making more technical redstone builds, like things that I've been making over here: binary data transmitters, binary adders and chip directors, so and so on. I'll be making lots of different vids like this. Wait, before I end that, I need to show you something with this carpet mod that I have. Turn this machine back on. If we do tick rate 100, this will look really cool. Yes, this is the perfect time to end the video with satisfaction. So, I hope you guys enjoy this video. Make sure Matt Batwings sees this video to see what I created and see if he can make it better for larger sets of data, of course. I mean, he already made the fastest, and at least for 8 sets of data. But I hope you guys enjoyed this video, and I hope you guys will watch more of them. See ya.